Next, let us discuss the subtraction of the vectors. To discuss the subtraction of the vectors, let us see the animation related to the subtraction of the vectors, how the subtraction of vectors is done. The origin and position vector of point A, position vector of point B. Say this is a good example for subtraction or difference of two vectors. That is vector joining 2 points. So here we have OA bar is equal to A bar and OB bar is equals to B bar. But here from the triangle we can have that OA bar plus AB bar is equals to OB bar from the definition of triangular law of addition. But here as I require AB bar, then AB bar is equals to OB bar minus OA bar. AB bar is equals to, therefore AB bar can be got by formula B bar minus A bar. This is B bar minus A bar. So this is a good example for difference of two vectors, that is subtraction of vectors. Now this subtraction of vectors, that is if A bar, B bar, C bar are any three vectors, then A bar minus B bar is never been equal to B bar minus A bar irrespective of they are null vectors, and A bar minus of B bar minus C bar is also never been equal to A bar minus B bar minus C bar. Now this subtraction of vectors in a triangle based on the properties will have these four properties of subtraction of vectors, since in any triangle, number one, sum of two sides is always more than the third side, and number two, the difference of two sides is always less than the third side. So therefore what you conclude is, here from this we learn the properties, that is properties of difference of vectors exhibited from the above criteria. Number one is, for A bar comma B bar are two vectors, number one is modulus of A bar plus modulus of B bar is more than or equal to mod of A bar plus B bar. First property. Second property is A bar plus B bar modulus is more than or equal to mod A bar minus mod B bar. And third property is mod of A bar plus mod of B bar is more than or equal to mod of A bar minus B bar. And the fourth one is mod of A bar minus B bar is less than or equal to mod A bar plus mod B bar. Let's have the proof of these things by taking a small diagram. Suppose we take OA bar as A bar and AB bar as B bar in a triangle OAB. There is a triangle OAB in which this is A bar and this is B bar. Obvious that this is the sum vector A bar plus B bar. So therefore here from property 1 mentioned above, sum of the two sides is more than third side. From triangle I can take, from triangle OAB, only side OA plus only side AB is more than side OB. Their magnitudes of vector OA bar, so I can write it is like this, more than OB bar. So that implies mod OA bar is A bar plus mod AB bar is B bar is more than mod of A bar plus B bar. Therefore we can conclude that mod of A bar plus mod of B bar is more than or equal to mod of A bar plus mod of B bar. So the equality holds good for, so in all the above the equality holds good for A bar comma B bar are null vectors. Next, in this, if we prove from the same thing, from triangle OAB, OA difference of AB is obvious less than the third side OB. If we take difference of OA bar minus AB bar is less than OB bar. It's obvious that mod of A bar minus mod of B bar is mod of A bar plus B bar. Therefore we can conclude that A bar plus B bar is more than or equal to mod A bar minus mod B bar. So same thing is applied, that equality holds good for A bar, B bar are null vectors in this property also. Next, third one is, we need to prove A bar plus B bar is more than or equal to A bar minus B bar. From 1, A bar plus B bar more than or equal to mod of A bar plus B bar. And mod of A bar plus B bar is more than or equal to, and mod of A bar plus B bar obviously more than or equal to mod of A bar minus B bar. Therefore, from transitive property, mod of A bar plus mod of B bar is more than or equal to. Equality holds good for A bar and B bar are null vectors. So from this, to prove this one, consider which can be written as mod of A bar minus of B bar plus of B bar. This is nothing but less than or is equal to, if I take these two together, mod of A bar minus B bar plus mod of B bar, that is A bar minus B bar. So here mod of A bar is this. Finally you can say mod of A bar minus B bar is more than or equal to mod of A bar minus mod of B bar. This is minus. Therefore, here also equality holds good for A bar and B bar are null vectors. So this is proved and this is proved and this is proved, this is proved. These are the properties based on the properties of sides of triangle with the third side. Sum of the two sides is more than third side and difference of two sides is less than the third side.